Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to begin our discussion on Choropleth mapping, which uses color, or the visual variables associated with color, to map and demonstrate and present data. So up to this point, we've talked about where color comes from. We've talked about the visual variables associated with color, that was hue, saturation, and value, and kind of what those meant in terms of colors that they produced. We talked about how we can communicate those colors to computers through the RGB, CMYK, and HSV color methods. So the color cube versus the color cylinder. And then now we're going to talk about this idea of Choropleth mapping. And I'm going to do 3 different videos, one on qualitative, one on sequential, and one on divergent. So let's go ahead and talk about the qualitative method of Choropleth mapping. Qualitative method of Choropleth mapping. Right, so the qualitative method of Choropleth mapping is going to be focusing in on that visual variable of hue. So qualitative method, as the name implies, is going to be focusing on qualitative data, so nominal and ordinal. And it's going to primarily focus on hue, right, the actual color, as the visual variable that we're going to use to represent data. So again, just to recap, right, qualitative, as the name implies, is going to be focused on qualitative data. So this is again going to be our nominal and our ordinal. Nominal and ordinal data. And it's going to be dealing with primarily hue. Right, it uses hue as the visual variable, or changes in hue. So there are really 2 types of qualitative Choropleth maps. There's classed and there's unclassed. I'm going to go through an example of each of these. So there's 2 types of qualitative Choropleth maps. Two types of qualitative Choropleth maps. There is the unclassed, and there is the classed. So unclassed is going to be where essentially the colors don't necessarily represent things. So you could think of this if you were to look at an old school atlas, for example. Maybe every single state has a different color. So they're there to allow contrast, but they aren't necessarily representing the data specifically. So this would be each observation gets its own color. And I'm going to put in here within reason. Within reason. Now, if you've ever heard of the 4-color problem in cartography and mathematics, it actually deals specifically with unclassed qualitative Choropleth maps, because the idea here is how few colors can we actually use such that no 2 colors are bordering each other. But the idea with an unclassed Choropleth map is that the colors aren't actually telling us anything meaningful. They're just there to improve the contrast between neighboring polygons. So we're not going to worry too much about unclassed for now. Just be aware that you will sometimes come across unclassed Choropleth maps where the colors aren't actually representing data. It's just there to improve contrast between neighboring observations. So colors do not convey data. Classed, on the other hand, is the one that we're going to spend a lot more time dealing with in this class, and this is where the colors actually do convey data. So the way this would work is you have, for example, we could use land cover types, right? We have forest, we have water, we have agriculture, we have urban, right? That's nominal data because it's in name only. But you might want to know, for example, what polygons in your map belong to a particular land cover type. So having those land cover types be represented by a color is going to be an extremely efficient way of communicating that information, right? You can look at the map and say, okay, well, if a polygon is yellow, then it must be agriculture. If it's dark gray, then it must be urban. And that's going to be a very quick way of conveying that information. But in this case, the colors actually imply something, right? Unlike the unclassed, where the colors don't mean anything, they're just there to help improve contrast, in a classed qualitative Choropleth map, the colors are actually telling us something. Let's go ahead and just look at what that might look like on a map as a quick example. Let's say we had some census tracts here. These are terribly drawn census tracts. Right. Let's say we had these census tracts here, and we had three classes. They were either predominant land cover, so we're going to make predominant land cover, right? And so we would have, let's say, for example, you could be either urban, which would be gray for urban. You could be green for forest, or you could be yellow for agriculture. Right, and so you could imagine this, let's say this was urban, so this would be colored gray. If this one was urban, it would be colored gray. And this one was urban, so it would be colored gray. Right, so we have three that are urban, and then we have agriculture, and then the rest would be forest. Right, so in this case, the colors mean something because we have a legend here associated with it, and we can quickly see, based on the color, what the underlying, in this case, census tract's predominant land cover was. Versus in an unclassed, right, you might have something like this, where you have, let's try my best to duplicate that again. Right, whereas with an unclassed, what you might have is the colors would just be structured so that they don't actually, so the two colors never overlap. But the colors don't actually mean anything, they're just there to improve contrast. So for example, if we did red and 3, right, and we could do yellow, and then we could do blue, and then we could do something like green down here, right? This would not be good because of red-green color blindness, but the idea here is that these colors don't actually mean anything. They're just there to improve contrast between this and this and this and this. So with unclassed, right, colors never border each other. Colors never share a border. Right, that's another thing for unclassed. Observations get their own color within reason. Colors do not convey data, and colors never share a border. Whereas with class, right, colors do convey data. And so oftentimes, because of the first law of geography, right, things that are closer together are more alike than things that are farther apart. We generally tend to see patterns in the data where we have things like urban taking up multiple census tracts that border each other. So in this case, right, class data would actually share borders. So hopefully this makes sense. I know it was a little bit of a reiteration of things, but again, just to recap, qualitative data focuses on qualitative data. Qualitative Choropleth maps focus on qualitative data. So it's going to be your nominal and your ordinal. And we're talking primarily about using hue as the visual variable. So we're changing color while keeping value and saturation the same. And we're going to be dealing with two types, primarily unclassed and classed. Unclassed, meaning that the colors don't actually mean anything within the data. They're just there to help create contrast between the two different polygons. And so the idea is you would never want the same color to border itself. And then we have classed, which is the main one that we're going to focus on, which is dealing with when we have data that is nominal, but where the groupings actually mean something. And again, I went through the example of land cover types, where you might want to know where the different predominant land cover types are, and you want to color them appropriately. So hopefully this makes sense. And if you have any questions, as always, please reach out. Thank you.